Just like length also cannot be negative. Yeah, I just unmuted for him. Why? What's wrong? Yes, Zhenjie. Never mind. It's just like our length cannot be negative. Money also cannot be negative. So in this case, we will. Oh, why? Oh, 15/2. This one is it? Is this what you're trying to find out? Yeah, okay, thank you very much. Negative 15/2 and or 7. Okay, right. So in this case, we have to reject our negative value. We are only therefore left with x equals to 7. And then the final portion says find the number of euros he received in 2014. Then after that, using x equals to 7, earlier on we had an expression for the amount of money received already. Amount received. Just substitute your x equals to 7 into the original. I think it was the answer in part A or part B. 7 plus 1, 140 euros. Okay. So in our WA3, in our end of year exam, we will very likely see one of these type of questions where you are tasked with forming the quadratic equation. Usually 2 types. First, money exchange. Exactly as what you've seen over here. The other type of question is for rate. Rate will be things like including speed, including things like getting a job done. How long does this company take? How long does that company take? You make a comparison, end up you have to form a quadratic equation. That will be part A and B. Then in part C, the next portion, they give you more clues so that you can form the quadratic equation. The final one will be solve, and the last part will be to obtain one piece of information from the original story. Okay, it is always the same structure. Next one is our drawing of our graph. So complete the table of values. Literally substitute all the x values inside. Every time you see it, be careful of negative signs for x. So when x is equal to -1, we have our y value to become -1 with a square, -5, -1 plus 3. So we have 1 plus 5 plus 3 giving us 9. Okay, this has a value of 9. Okay, can you see any symmetry in the table of values? Can you see the symmetry? Cannot. The symmetry is over here. 1, -1 and -1. 3 and 3. I expect this value to be -3. I expect it to be because it is symmetrical. Let me just verify that. When x has a value of 3, 3 squared, so 9 minus 15 plus 3. So 12 minus 15, -3. Okay, that's shown. This is one way you can check your work. And then when you plot, I'm telling you now, when you plot for the upcoming WA, for the upcoming end of year exam, the only parabola you will see will look like this. Okay, must be symmetrical, or it will look like this. Confirm. Smiley face, sad face. There could be an instance when you are trying to plot and your plots end up something like this. Are you able to look at this now and say that something is wrong already? You can tell something wrong, right? You will not be asked to draw such a curve. Don't have. Which point do you think is wrong? First, second, third, fourth, fifth, or sixth? Most likely the sixth one is wrong, right? Then you go and check your substitution over here. Okay? Don't go and force yourself to end up drawing a weird graph like this. It has to be symmetrical. No. Make sure you know when you did something wrong. Then you can check. Okay, in this case, as shown, the parabola over here. Now this is not a weird shape, no, because they only ask you to draw until x equals to 5. If you were to continue, it will continue to be symmetrical. This way. It just keeps going on and on forever and ever. Okay? This one over here looks like it is not symmetrical because you are forced to end at 5. If you continue, it will be symmetrical. Okay, using your graph, find the values of x when y equals to 2. All these are your Sec 1 knowledge, Sec 1 skills. When y equals to 2, draw a line, y equals to 2, find the x values. What is the common mistake? Is, yeah, I know, supposed to draw y equals to 2, then you draw like that. Then you're happy already. Then you only end up with one answer for x. What about the other one? You're supposed to continue drawing. Because the line of x, y equals to 2 stretches on forever and ever. If you stop halfway, you're not going to get two answers. So the two answers will be 0.2 or 4.8. Allowance is plus minus 0.1. So as long as you're within plus minus 0.1 of either of both of these two answers, you are okay. Write down the line of symmetry. The line of symmetry can be obtained from the graph visually. You just need to look at where the minimum point is, minimum or maximum point. That will give us a clue where the line of symmetry is. And it always starts with x equals to something, in this case 2.5. All right, in Sec 2, your line of symmetry will be x equals to something for your parabola. Just to let you know, in I think Sec 3, you will learn parabolas that look like, you may learn parabolas that look like this. Now, if it is of this shape, then the line of symmetry will have a equation y equals to something. You get it? Y equals to my horizontal line. So if your parabola looks like this, the line of symmetry is y equals to something. But now in Sec 2, we only have happy face, sad face. So the line of symmetry will be x equals to vertical line. So minimum value of y. See how you have to pay attention to the words that they use. Minimum value of y. They did not ask for coordinates of minimum point. If they say coordinates of minimum point, they want x value, y value. If they say minimum value of y, they just want the y value, the y coordinate of the minimum point. And the accepted answers are -3.2, -3.3, -3.4 in this particular case. And we have the other standard question also. Y equals to, oh no, this is not too standard. Y equals to k to be drawn to solve this equation. X squared minus 5x plus 3 equals to -12. Let's check back what we have already drawn. Y equals to, is it x squared minus 5x plus 3? Y equals to x squared minus 5x plus 3. This is already drawn. Our objective is to make whatever is given to us in this new question look like the equation of the graph that we have already drawn. In this case, very nice to you. They already have it in the same format. So watch. X squared minus 5x plus 3 plus 3. So nice to you. In other words, all you need to do is just to draw the line. Therefore, draw y equals to -12. Okay, draw the line y equals to -12. So let's go back to the graph. Oh, is there space for you to draw y equals to -12? No space. Your graph only ended at, there was only space for -4, y equals to -4. They did not ask you to draw, right? They say a straight line is to be drawn. They didn't ask you to draw. Huh? So if you were to draw that line, y equals to -12, which obviously is way further down. So let's just compress it a little here. Y equals to -12. Does this horizontal line, y equals to -12, intersect your curve? Do they touch? No, they don't touch. Do they intersect? No, they don't intersect. If they don't, then is there any solution? There's no solution. Literally, there is no solution. How many solutions would there be? There will not be any solutions. The line y equals to -12. See, they didn't want to tell you what the line is. They only say y equals to k. You are supposed to find out, and you have found out that y equals to -12. Does not meet the parabola. Y equals to, what is the parabola? X squared minus 5x plus 3 at any point. The line y equals to -12 does not meet the parabola y equals to blah 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 at any point. No meeting, no solution. Simple straight lines. Y equals to 1, y equals to 3. Do these two horizontal lines intersect each other? Y equals to 1, y equals to 3? They don't intersect. They will not meet each other. So if I ask you to solve simultaneous equation, solve y equals to 1 and y equals to 3. Can you see that this is a nonsense question? There's nothing to solve on. Is y equal to 1 or y equal to 3? There is nothing to solve. No solution. Similarly, if we have y equals to x plus 1, y equals to x minus 1. These are two parallel lines. If I ask you to solve y equals to x plus 1, y equals to x minus 1 simultaneously, let's see what happens. Equation 1, equation 2, do a subtraction, maybe equation 1 minus equation number 2. So y minus y, 0. X plus 1 minus x minus 1. X plus 1 minus x plus 1. X minus x is 0. 1 plus 1 is 2. 0 equals to 2. Rubbish. There is no solution. Because the lines don't meet each other. If they don't intersect, there is no solution. Okay? Shown over here. Then in our parabola with straight line, we can have one solution looking like this. This also shows one solution, because only meet one time. This means no solution. This means two solutions. The number of points where they meet will be the number of solutions. Okay, next one, question 6. So we have a curve y equals to x plus b. They didn't tell you the value of b. And they also tell you that the next part, x minus 5. The thing about quadratic equation in this format is that you can tell the x-intercepts very easily. Because when you set y equals to 0, when y equals to 0, That is, you want to find the x-intercepts. You end up with x plus b equals to 0 or x minus 5 equal to 0. Now these two will give you a solution of x equals to negative b or x equals to 5. X equals to 5 is shown here already, which means that this value here, it has got to do with b. It has a value of negative b, but I don't know what that is yet. Let's look at the next clue. Line of symmetry at x equals to 2. Line of symmetry passing through the middle, lowest point. This is x value 2. Line of symmetry tells us that left side, right side same. So if I have 3 units here, then there must also be 3 units here. Only then can we say that this is a line of symmetry. If this is a value 2, then there are 2 units here. Then only 1 unit here, 1 unit. So we therefore conclude that this is a value of negative 1. 3 units. From negative 1 to 2, 3 units. From 2 to 5, 3 units. So that's our line of symmetry. Find the value of b. So earlier on we solved already. X plus b equals to 0. X equals to negative b. X equals to negative b. This is my value of x. So negative b equals to negative 1. B equals to 1. Our b value is 1. It is not negative 1. If you are confused about this portion, you just need to substitute back into the original equation. Ask yourself, when y equals to x plus 1, because that's what we are saying b is. We are saying that b is 1 and x minus 5. What would your intercepts be? In this case, your intercepts will be x equals to negative 1. Yeah, that's correct. As well as x equals to 5, as shown. If you were for some reason going to be confused, you put x equals to minus 1. Sorry, x minus 1 times x minus 5. If you solve this, you will obtain x equals to 0, x equals to 1, x equals to 5. X equals to 5 is correct. But look, this is not x equals to 1. So it means that it cannot be minus 1. It has to be plus 1. Okay, any questions at this point? Okay, next. Coordinates of the turning point, once you get an x value already, they gave it to you. You just need to substitute into the equation for the y value. Then for the y-intercept, substitute all the x values to be equal to 0. Okay, y-intercept is always x equals to 0. Coordinates of turning point, x value is from line of symmetry. Okay, anybody needs more time for this? Moving on to Pythagoras theorem. Right angle triangle, they tell you it is right angle triangle, so you know that, confirm use Pythagoras theorem. Short side, square it. Short side, square it, add them up, must be equal to the square of the longer side. Just a reminder for your expansion. Easy to say, square the 2x, but what would you obtain? Are you going to get 2x squared or 4x squared? So be very careful. When you square the 2x, you're going to end up with 4x squared. When you square the x plus 5 squared, you are going to end up with x squared plus 10x plus 25. This is your, this was covered some time back. So please do not make this mistake in red. X plus 5 squared equals to x squared plus 5 squared. You get x squared plus 25. This is wrong. Do not make this mistake. So obviously the same for the other side. 3x plus 1, when you square it, you get 9x squared first, plus 6x plus 1. So then from here, we end up with a quadratic equation again. X squared minus x minus 6 equals to 0. See, they tell you to show again. Show that it simplifies too, because subsequently they will want you to use it again. Solve that equation. You can solve it already, ending up with 2 answers. And you are expected to reject x minus x equals to -2, because x cannot be negative. Look, one of the sides of the triangle is actually 2x. If your x is -2, you are implying that the side has a distance or has a length of -4 units, which cannot be the case. Length has to be positive. So we take this away, leaving us only with x equals to 3. And now we have all 3 dimensions of the triangle already. So find the longest length. 3x plus 1 was the longest length. So 3 times 3 plus 1, 10 units. Wenxuan, you get it correct? Okay, question 8. A, B, C are 3 points on the ground. So this is a 3D diagram already. They are on the level ground, X and Y. They are the top of 2 vertical poles at A and B. And then the dimensions given, AB 1.18, 0.8. Okay, so we can identify this actually is a right angle triangle. You just have to see it from the side. If you cannot tell, sketch it out. A to C, 0.8 meters. And they say that there's a vertical flagpole. This will be our point X. Okay, this is one of the triangle. So find the height of the pole at B. The question here is for this height. Okay, this height is divided into the breadth, the height of a rectangle, as well as the height of this little triangle. We can find the height of this little triangle that I'm going to highlight. This portion we can find, because we are forming a right angle triangle on top. We've got a hypotenuse as 1.2. We've got a base as 1.18. Okay, same base, 1.18. So I know confirm I can get this little value. What's left will then be this distance, which is the same as my XA, which is this distance, which I can also obtain because I've also got a hypotenuse 1.2. So I'm going to employ Pythagoras theorem twice. First, in this triangle to get a height of XA. Then we're going to employ Pythagoras theorem again for the highlighted distance. In both cases, both are right angle triangles. I've got both of their bases and their respective hypotenuse. And here's the working. Okay, copy down the corrections. So we've got two different two portions of the height added up to give us 1.11 meters in 3SF.